Welcome to this video on simulating Gibson assembly with Genius Prime. In Gibson assembly, multiple DNA fragments with homologous ends are mixed together. A T5 exonuclease then chews back the nucleotides from the 5' ends of the fragments. This process allows the overlapping homologous ends on the different fragments to anneal. DNA polymerase fills the non-complementary sequences. And finally, DNA ligase seals adjacent nicks. The result of Gibson assembly is a scarless joint of multiple DNA sequences. That's a brief overview of Gibson assembly. Now let's simulate this process in Genius. Begin by preparing your multiple DNA fragments for cloning, such as a vector, and insert. To prepare a vector for Gibson assembly, identify the region you want to linearize in the sequence. For example, to create a fusion protein between our insert and the green fluorescent protein GFP, linearize the vector just before the ATG start codon of the GFP gene. To linearize the vector at the desired site, use either PCR or restriction digestion. For the restriction digestion, click Cloning and choose the Digest into Fragments option. In the new window, select your desired restriction site and click OK. The resulting file will contain two 5' overhangs, which the T5 exonuclease enzyme will digest during the Gibson assembly. If an overhang contains part of the sequence you want to retain in the final plasmid, such as an ATG start codon, you can manually add the nucleotides back in. To do this, select the Allow Editing button and manually add the sequence back in. To correctly incorporate this addition into the primer extension, you need to annotate it with a specific Gibson primer extension annotation. Do this by highlighting the new sequence and select Add Annotation. In the new window, give the annotation a suitable name, and for the type, manually enter Gibson primer extension. Once done, click OK. Ensure you save your changes by pressing the Save button, and if prompted, deactivate the links to parent files as this is not needed. Your vector is now ready. Next, prepare your insert. In this example, to create a fusion gene, we select the coding sequence for our gene of interest without the stop codon. Once you're happy with your selection, click Extract to save it as a new file. Give the new file a suitable name and click OK. We're now ready to simulate the Gibson assembly. Begin by selecting your linearized vector and the insert files. Then click Cloning and choose Gibson Homology Cloning. Genius will automatically select the linearized vector file as the backbone in the new window. However, if it is not already selected, you can use the drop-down menu at the top to choose it manually. Ensure exonuclease is set to 5' exonuclease. For a method that uses a 3' exonuclease, such as sequence and ligation independent cloning or infusion cloning, you can select 3' instead. Click the individual tags to preview the sequences used in the assembly. To adjust the primer settings for the simulation, select Primer Options. In the new window, adjust the minimum overhang length. This is the annealing basis length that two neighbouring sequences will have in common after the operation. We recommend leaving this set to 18 base pairs. You can also adjust the minimum overhang melting temperature. This value is the minimum melting temperature allowed for the annealing region between two adjacent sequences, not to be confused with the primer melting temperature. The settings at the bottom calculate the primer melting temperatures. If you use a fusion polymerase during the Gibson assembly, we recommend changing the formula to Breslauer et al. 1986. Once you're happy with the primer settings, click OK. Finally, click OK again to run the Gibson assembly simulation. The final step in the Gibson assembly simulation is to analyze the results. After performing the simulation, you will see a Gibson report, ligated sequence product, and generated primers in the document table. The Gibson report contains a text breakdown of the simulation. The Hints section lists any manual modifications to the primer sequences, such as the addition of bases. And the Generated Primer section of the report lists the forward and reverse primer sequences. Each primer created by the simulation also appears as separate files in the document table. To preview the final plasmid, select the Gibson cloning ligation product. Here you can zoom into the sequence to ensure the site's ligated sequences are as expected and check the resulting protein is in frame. You can also mouse scroll over the primer annotations to view the primer characteristics, binding sequence, and extension sequence. Genius can also handle batch Gibson assembly operations using a sequence list document. This feature is useful when creating multiple products within a single Gibson assembly simulation, such as creating a fusion gene with different gene promoters. To perform batch cloning, you need a sequence list containing the different sequences of interest. Each sequence in the list is used to create a separate product. In addition, you need to select the other linearized sequence or sequences you wish to clone with the batch sequences. Then, as before, go to Cloning and select Gibson Homology Cloning. Again, ensure you select the appropriate backbone file and confirm 5' exonuclease activity. In the preview window, the brown color identifies the sequence list tag. Click and drag to move the sequences into the desired order. We also recommend saving the results in a subfolder for convenience. The resulting batch cloning will produce separate product and primer files for each sequence in the sequence list. Additionally, you can refer to the Gibson report to view the generated sequences and primers. Visit genius.com for more hands-on exercises and tutorials.